All right, let's get started. Is that still a feature on Piazza? It's ridiculous. So when you do a poll on Piazza, after people start voting, you can change the text for the options. Just make it look like they vote for whatever you want. It's ridiculous that would be a thing. But and students can make polls, so I mean everybody can do that. Ridiculous. Morning, everyone. All right, let's do this. So we want to finish up these slides from last time. And I forget every time, I'll blame it on Apple because they updated OSs. Can't possibly be my fault, but I forget how to zoom in on Mac. If anybody knows, it'd be fantastic. I was trying to look it up just real quick before, except I was searching in magnifier or the Spotlight instead of Google. That's what I should have done. All right. Talking about forward secrecy. We talked about this big vulnerability that certificate authorities are going to solve. So our certificate authorities are going to sign our public keys for us. And I wanted to demo that. I don't know how well I can do it without being able to zoom because I can't zoom in on these. But if you go into this lock, that lock means, hey, you're encrypted. And the encryption keys are verified. So if we click on this, connection is secure, certificate is valid, we can take a look at their certificate. And I'll take a wild guess at it. Not any of those. Right. I'm going to try it real quick. Zoom, magnifying glass, OS X, spelled incorrectly. How to zoom, built-in magnifier, system preferences, accessibility, zoom. Just tell me what the keyboard shortcuts are, for frick's sake. Settings, accessibility, zoom. Toggle zoom. What is it? Oh, use keyboard shortcuts. I swear that is actually the first shortcut I tried. I actually did remember it. Oh, thank goodness. All right, here we go. That is actually the first shortcut I tried, but it's disabled by default. That's ridiculous. Who would accidentally hit those keys? All right, so we can take a look at our certificate. And if I resize this and zoom in, we can see, but I have to be very careful about where I choose to zoom. I can see that CSE 312, the certificate, it's valid, and then it moves. Oh, this is always a pain. And we can see all the details of this certificate. Oh, good, I can scroll in here, though. This is a certificate for a specific domain name. So to get a certificate, you have to prove that you control that domain name, and then the certificate authority is going to sign that public key and then issue a certificate with all kinds of information, including the public key itself. So we can see who encrypted it. This is Let's Encrypt. Let's Encrypt's R3 CA. This is signed. It's a signature of the a hash of the signature. So we're using RSA to verify, to sign the certificate. The CA takes their public key or their private key and signs the certificate with that private key so everybody can verify the signature, and also hashes the entire certificate, including the signature, so we can hash that and verify that the hash matches as well. So if somebody wants to break a certificate, if somebody wants to create a counterfeit certificate, they're breaking RSA and SHA-256 for this particular certificate. It's going to be pretty tough for them to do. They got to break both of them. We got all the valid, the algorithm that's being used, the key size, 2K, and somewhere in here we should see the actual public key. Somewhere we have some elliptic curve stuff going on. And we don't actually get to see it in here. So it depends on which window you look at them in. But somewhere in there, I promise the public key does exist, even though Opera doesn't feel like showing it to me. So when we go to these, actually, I think I can go up here. Let's try this. Root canal, that's what I wanted. Keychain. Keychain access. And if I look at my keychain, this is installed at the operating system level, and I have all of the root certificate authorities. These are the public keys that I trust because they were installed either with my OS, my browser, during some secure installation process. We have all these trusted keys. Oops, I'm in the wrong tab. All these trusted certificate authority keys, and we can be reasonably assured that anything signed on anything on this list is going to be trusted. Anything signed by one of these private keys associated with these public keys that I have. If you look at your root CA keys in your keychain on your computer, you'll probably have the exact same list. I don't know if there's any variance at all, to be honest. There may be one or two, I don't know. But it should be pretty much the same list. It's the same list of trusted CAs that are out there that we all are going to assume are legit. Now, some way, somehow, somebody could have got a counterfeit certificate in here, and if they did, they can do a lot of damage. There was an attack fairly recently, I want to say, but it was like probably 5 years ago by now. Time flies as it keeps going. But where somebody did get a counterfeit certificate in one of these root CAs and did a lot of damage, as you would expect. They can really break things because there is no trusted security at that point. Once you're signing things with a counterfeit certificate that an attacker controls. So if we look in this list, anything that's signed, any certificate that's signed out there, any certificate we use for encryption to get this lock has to be in this list, has to have a keychain that's verified by something in this list. So if we look at our certificate, it was signed by Let's Encrypt R3, which I'll tell you right now we're not going to find in this keychain. So I'll go to R's. This is always the biggest challenge. I have to remember the alphabet. And there are no R's, so and it's not in there. So we can go to L, which I passed. L, there's no L's either. They're really making it tricky on me. I have to remember where the letters are. So there's no L's, no R's, and I wasn't zoomed in, so you couldn't see anyway. But that Let's Encrypt certificate is not in here. We're not going to find it anywhere. That's because that certificate is signed by a root CA. So if we take a look at this Let's Encrypt certificate, it's, in fact, signed by this ISRG root X1, and we can see all of the details of this thing. They're also using SHA-256 with RSA encryption. Everything's there. Signatures are there, all kinds of information about the certificate. And it's signed and that certificate is signed by this ISRG. Oops, wrong button. I had to click so many times to get to where I'm going. Then we can see the details about this one. This is not verified by anyone. This is a root CA, so we're going to trust that it works. They're, in fact, using the same algorithms, just as a coincidence. But we would expect to see a very large key size on these root certificates. You're going to see large key sizes everywhere, because why not? But you're going to really see the large key sizes on these root CAs, because these root CAs have to last a long time. 2035, people have decades to be able to crack this key. So we want to make sure we get enough security that it's future-proof, that even in 2030, some new technology comes out where they can crack these keys faster and crack these, given the public key, generate the private key. If they can do that even faster, we want to make sure it's future-proof like that. So 4K is a pretty big key size. If we do get that full entropy, that's 4,000 bits of entropy. That's a lot of entropy. Like, they actually have to have a focused attack. They will not break this with brute force. It's just not going to happen. And all the other information. But no signatures on this one because it's self-signed. So ISG, I'm forgetting what it was. So ISRG root X1, that's our end of our keychain. That's the last key in this keychain. That's the last certificate authority. So we sure better have that one in this list. We go to ISG root X1. It's going to be in our keychain. It has to be because the browser's not complaining about it. If we have a keychain that doesn't end in a root CA, that's where you get the security warnings in the browser. The browser's going to be like, yo, you really shouldn't trust this site. Don't be careful of what you're doing around here. If it doesn't end in a root CA, even if the certificate is signed by something, some entity signed that certificate, if it doesn't lead to a root CA, one that's installed on your machine and presumed to be trusted, it's not a valid certificate. Even if it's not directly self-signed, even if somebody else signed it, but that signature can't be verified by a root CA. It's still self-signed. It's a security risk. You're going to have that lock with the You'll have the lock with the slash through it and say, this is not a secure site, even though it is encrypted. And you don't want that on your sites. You want to make sure you're going to a root CA. Some sites, like Google, I mentioned briefly last time, if we look at their keychain, oh, they're actually not self-signed. I thought I checked one before and it was self-signed. Maybe they changed that? I don't know. Or does the G in GTS stand for Google? Oh, yep, Google Trust Services. So Google is kind of self-signed, but I mean, if you don't trust Google, you're kind of screwed anyway, or just don't use Google. So if you're on Google's website, there's some presumed trust that you do trust such a large entity. So take that for what it's worth, or make of that what you will. I mean, but Google certificates are self-signed, but I mean, it's Google. Like the actual root certificate authorities, have you ever heard of them? You don't even know them to know if you actually trust them. But they're trusted by so many entities out there that we pretty much just take it for granted and say, yeah, we'll trust them too. What other option do we have, honestly? Not use the internet? But Google's big enough that they are self-signed. They have their own root certificate authority in-house, and they're signing their own certificates, so they don't have to pay somebody else to do it. And we can see GTS root 1, 2, 3, and 4. So Google has 4 root certificates on my machine right now. And surprisingly, GoDaddy. I'm always surprised to see them anywhere like in a legit place. Not to pick on them as a company, but with their advertising, their marketing campaigns, it's hard to take them seriously after that. Yeah, any questions about this? Apple makes macOS intuitive. Apple used to be a lot better. I don't want to go down that rant, but it used to be a lot better. They're really falling off now. Though anyone who has an M1, I hear great things. So, but on the usability side, they're slipping. GoDaddy is the worst. GoDaddy is kind of the worst. They spend a lot of money on marketing and then they upcharge you for everything. There are a lot of cheaper options out there that give you better features. But I just don't mean to pick on them specifically because there's a lot of bad hosting site services out there. No, Google is not considered self-signed. So it's like technically self-signed, but that's not, we would not consider that a self-signed certificate. I say that kind of tongue-in-cheek, like, oh, Google is self-signed because they have their own root CA. But it is still a trusted certificate because it is signed by a root CA. So no, that would not be considered actually self-signed. Now I forgot my keyboard shortcut there. All right, no questions about certificates? We got our certificate example. Yes, Nicholas. Oh, for 312.com? Yeah. Through Let's Encrypt, the cert bot.
So, I mean, like, when you go to 312.com on some client device,
Mm-hmm.
how does your computer obtain the certificate that proves that you're connected to the right server?
By requesting, good question. So when you connect to a site, you're requesting, saying, hey, site, give me your certificate, is one of the first forms of communication. Before you're even requesting any HTML, you say, give me your certificate. It's sent over this untrusted internet. It might have been swapped out. There might have been a man-in-the-middle attack. Anything might have happened before I get the certificate. So when I get the certificate, I'm going to check the signature, see who signed that, get the next certificate of the CA that signed it. I'm going to go to that CA, say, hey, I need your certificate if I don't have it in cache. I'm going to get that certificate, and I'm going to check the signature of that. And then if that checks out, I have, if that's signed by a root CA, I'm going to verify that by checking my root CA certificate that I already have on my machine, which is the only thing I'm trusting. So if that verifies the CA certificate, the root CA certificate verifies the CA certificate, and the CA certificate verifies the CSE312.com certificate, then I'm reasonably assured that there was no attack that happened. So if I got a certificate that's actually signed by a CA and everything checks out up the keychain, then I'm going to say, okay, I must have actually gotten the right certificate.
So is the certificate sent through HTTP protocol, or is there a different protocol?
It would be sent through TLS. It would be it's part of the TLS handshake. So that's over TCP, but not by the time we get to the HTTP. We're not at the HTTP part yet. So no HTTP communication yet, but we established the TCP connection. We did that three-way handshake, and then we're going through the TLS handshake to be able to encrypt the traffic. It's part of that process. So it's not something our apps will ever see. It'll be happening before our apps.
So like the reverse proxy handles sending the certificate in the handshake?
Yes. Yeah, the way we're going to set it up this week, we're going to have our reverse proxy of nginx. It's going to handle all that handshake for us. And then by the time anything gets to our server, it's just going to be what we've been seeing all semester. Yep, no problem. Homework 4, the testing procedures, does opening a different browser really mean another browser or tab? It actually does mean another browser. That is the reason I worded it differently for this one. It does mean another browser because if you open another tab, you have the same cookies. So I actually do mean open like Firefox and Chrome or Opera, actually two different browsers. Because they're not sharing cookies between browsers. That would be a big security issue. You can't share cookies between browsers, so that's our way of guaranteeing that you can be logged in as two separate accounts on the same machine. If you have another way of doing that, be my guest. If you want to open a new tab and like clear cookies, but that'd be more hassle than it's worth. And it would only make sense if your app doesn't work on all browsers, which it really should at this point. Oh yeah, new incognito window too. Good call. Yeah, or open a few incognito windows of the same browser. If you want a bunch of Chrome browsers with the same window, or with the same browser but different windows, that would work too with incognito. All right, so let's talk about self-signed certificates, because this is what we're going to do for the homework. A big step in getting a signed certificate is proving that you control that domain name. Well, we're not getting domain names, so we need to do self-signed for the homework assignment. If you want to get a domain name and get an actual signed certificate from a root CA, I will demo that. That might be coming. It's coming either Wednesday or Friday. I'll show you how to do it. I'm just not requiring it for the homeworks because it costs money, and I'm not going to force you to pay money to take a class. But it's not that big of a deal. It's actually a little easier than the self-signed certificate path. And I'll show you. I'll let you pick a domain name. I'll buy a domain name. I'll go get it, get HTTPS on it, get the cert installed, and all that stuff. I'll demo that. It's actually pretty easy. I use something I mentioned a few times, something called certbot. You just type one command and it just does it, and it's free. The certificate itself is free, but you have to control the domain name, or else it isn't going to work. So if you want to build an app and deploy it out there in the world, you need a server. I use DigitalOcean personally, and buy a domain name, which is like $12 a year. DigitalOcean is like $5 a month for the lowest tier. So if you want to spend a little money and have an actual app out there deployed, I'll show you how to do that this week. So first, let's talk about self-signed certificates. This is what we'll do for the homework because it's free, yes. Self-signed certificates are certificates that don't end in a root CA. So that's going to be the official definition. So as you know, in chat, the lecture question was mentioned. Any certificate that doesn't have a keychain that ends with a root certificate authority. And that's what we're going to, yeah, thank you for the shout out, Nicholas. I'm not going to make you pay $12. Yeah, because I could, no, never mind. But because I could figure out the server issue. It's not the easiest problem to solve, but I could figure out the server issue to save you the $5. But the 12, without buying you all domain names, I can't really get around that. And that's one of my philosophies. I'm never going to have somebody pay, even if it's 50 cents. I'm not going to have you pay extra to take a class. You already paid tuition. I think it's not okay that that's so common to make you pay extra money. But I don't want to rant about that. I could rant about that for a while. I'm sure you'd agree. But let's. So any certificate that does not have a keychain that ends in a root CA. So the Google certificates, they're not considered self-signed. They are, I don't even know what the opposite of self-signed is. CA signed? I don't know. But anyway, they are not self-signed because they do lead to a trusted root certificate authority, even though both entities are Google. You know, it is what it is. Self-signed just means you have some certificate where the keychain does not end in a root certificate authority. For the homework, you're going to be signing your own certificates, so you'll generate your own public key, private key pair, and then you're going to sign the public key and generate a certificate in a standard format. If that sounds scary, don't worry. It's just literally one command that you're going to cut and paste. And that certificate is going to be the one that you're going to host. It's literally signed by you. It is literally, in the truest definition, self-signed. That's what we're going to use for the homework assignment. And you can't go to a CA and say, "Can you sign something for localhost?" It just doesn't quite make sense. I was trying to make it make sense. I got this question earlier in the semester. There's no way that I could make that make sense, unfortunately. But no CA is going to sign you something for localhost. But yeah, development and educational purposes only. Please do not use self-signed certificates out in production. Get yourself an actual signed certificate when you're going out there in the real world. But for development, I have a lot of self-signed, I shouldn't say a lot, but I use self-signed certs for when I need encryption. So I might as well just talk about the specific use case. It's an app where we have a web server, but we use it on mobile and web. And iOS phones, more commonly known as iPhones. I don't know why I said it like that. But iPhones will not connect to a site. I don't know what the conditions are exactly, but I don't think they connect at all to any site that's not encrypted. Is that true? That, as I'm saying it, that doesn't sound true, but this is why we set it up like this. So to be able to test on iOS devices, we needed to be encrypted. And even if it's a self-signed cert, it'll give the warning and you say, "I know the risks," or whatever. And you can still use the app. But if you're not encrypted at all, it just won't connect. So we needed a self-signed cert so we can run the app on localhost and then connect with Android, iOS, and web. So we connect on all three environments, then test on all three of them. Without the self-signed cert, we wouldn't be able to test on localhost at all. So that was our workaround for that. We just got a self-signed cert, generated our own cert, and then installed it to our app. So we run on localhost, HTTPS localhost. So there are use cases in development that, once we go through this, you're welcome to use. So you can actually test your iOS, test your web apps on iPhones would be the use case there. I guess technically it is iOS because you could use an iPad too. Does anybody use iPads anymore? That's still a thing? I don't know. To take notes? Okay. So, but they're not using our app on it, so we don't have to worry about that. I could say iPhone then. And educational purposes, as we're doing here, of course. But anytime an actual user is going to touch your app, please, please, please be using an actual certificate signed by a root CA with a keychain that's signed by a root CA. Don't use these self-signed certs out there in the real world. We're going to use a library called Openssl, which got quite a bit of infamy not too long ago. Again, I say not too long ago, but it was probably 5 or 10 years. I don't even know. I have no concept of time after, in a previous semester. I know this semester and everything else is the past. Everything forward is the future. But sometime in the past, Openssl had a big security vulnerability, Heartbleed. You may or may not have heard of that. It's long ago enough that you might not even been into computer science at the time, but maybe. But anyway, it was a Heartbleed. It was a buffer overflow attack. So if you've seen buffer overflow attacks in other courses or anywhere else, that vulnerability existed in Openssl, and then it allowed people to get access to any arbitrary information on your server, which we consider as bad. It was a bad thing. So they patched it right away, of course, as soon as the news came out, but not as soon as they were aware of the vulnerability, for what it's worth, which is always scary. But anyway, so Openssl. You can use this in many languages. You can use Openssl right from your code. We're going to use it right from the command line, though. We're not going to bother with the wrapper libraries in this course. But if you want to use Openssl in your actual code, you have that option. There are all kinds of wrapper libraries for it that just make the system calls for you. So what we're going to do is generate our keys, sign a certificate with our public key, and we won't actually validate certs, but we could. And the big command that you get to cut and paste is this one right here. So if you install Openssl, if it's not installed with your operating system, if it's not already installed, install Openssl. It should say once Openssl is installed. On Windows, you're going to have to do that, which is Google install Openssl Windows, and it'll show you how to do that. Then running this command is going to generate your public key, sign it, generate the certificate for the public key, and generate and store your private key. And I'll go through what all these commands are, just in case you want to change some options. I'm sure for the homework you won't, but if beyond the homework you want to do something else with these things, you might want to. For your homework, just cut and paste this and generate your stuff. So when you do enter this command, the Openssl library is going to ask you like 5 to 7 questions. I forget how many. It's going to ask you a lot of questions. Most of these are optional, and you can just hit enter to leave them blank. It's going to ask for like your email address and some other information like that. Most of that is optional, but you need to enter the country code. So whenever I ask for country code, I just hit US, enter, and it works. If you don't do that, things just break. I don't know why, don't ask me, but you need to enter the country code or else things break. The rest of the questions are optional. And I'll demo this by the end of the lecture today. So these options, let's go through these one at a time. Request a certificate. This is going to say, hey, Openssl, what I want to do is generate a certificate in the X509 format. X509 is the standard for web certificates. When you go to a website and you're getting a certificate, it's going to be in this format. That's what the browser is expecting. So let's generate certificates in the proper format, X509. I want a new key pair. So this part is going to generate my public-private key pair. And I'm going to specify the algorithm and the key length. So I'm going to generate 4K key sizes, a key of size 4K, I should say, using the RSA algorithm. RSA is still used. You saw with my certs. Like, I didn't choose those algorithms, by the way. I just said, certbot, give me a cert. And it chose RSA and SHA-256. These algorithms are still used out there. I didn't just choose them arbitrarily or anything. They are actually still used. RSA, we're just going to use them for our self-signed as well. RSA has a lot of staying power. RSA has been around for a while, and it's still being used in practice. Key out, private.key. This you can change if you feel like changing it. Key out means save my private key, and then private.key is the file name where it's going to be saved. So this is saying save my private key in a file named private.key. Same thing with the cert-out, cert.pem. Save my certificate in a file named cert.pem. When should this thing expire? It's going to expire in 1 year by specifying the number of days. You can change that if you'd like. 1 year, I mean, we're not going to grade your assignment after a year, so you'll be fine with 1 year. And -no DES, don't require a password to use the private key. Because you're not going to type your password every time you use this, every time your app gets a request, of course. So we have our cert. Now we could do this in the code. Last time, I haven't required this for the homework in a while, but last time I did, I had you add it to the code, or I had that class, add it to the code directly, and your app would speak HTTPS, which you can do. It's perfectly valid and everything. But it's generally, I don't know, I don't like it, I guess I should say. But generally, it's not something you're going to do. Instead, we're going to use a reverse proxy server. We're going to start talking about how to set those up. I'm going to show you specifically how to use nginx. You're welcome to use something else if you want. Apache is the biggest competitor, but I'm going to show you how to do it with nginx. Yep.
On the last slide, when we run that command, where does it save it on our computer? Does it matter? Is it on our local machine, or does it have to be?
It's going to be saved in the directory where you run the command. So if you run this from the root directory of your project, you're going to get those public and private key in that directory.
So we should do that.
Yeah, you should do that. Because we'll need these, like when we run your app, we'll need your public-private key pair. So we'll need those. And I'll show you, I'll do a demo, probably Wednesday we'll get to this part of running the whole thing. And I'll show you that these need to be, the TLDR of it is we're going to create another Docker container for nginx, and that container is going to need the cert and the private key. So we need to get those inside that container one way or another. And they need to be in your zip file for your submission. And I'm going to try to do the reverse proxy stuff with no slides. I don't plan on doing any slides for them. I might cave later in the lecture, later in the week, if it's too much to do without slides, but I'm going to try to do it just purely through demos. And you can watch the videos to get the demos. Or just look up documentation. A big part of this course is looking up documentation. You can look up nginx, how to use nginx with Docker, if you don't like my demos too. Can I sign my certificate? Someday. I want to set that up in the course where you have to get your certificate signed by me, but I don't know if that makes sense. But I do want to do that someday. So like you have to actually communicate to my CA, and it would still be self-signed, but or could I? If I act as a CA, could I sign for localhost then? I think I might be able to. I'll have to think about that one. That'd be awesome if I could do that. iPads use iPad OS now. It's a different operating system. Why are they maintaining 3 different operating systems? Seems like a lot of work for Apple. It was in 2014, so 6 years ago. Heartbleed is the vulnerability. Yeah, so 6 years ago, you were all in high school, presumably. And you may or may not have cared about tech things at that point. Just perfectly fine. I suppose if you don't install OpenSSL and you use some other means to generate your self-signed cert, like, I mean, me and the TAs would never even know, so it's not really something you need to get approved. We'll never know. And I'm fine with that. If you have another way of doing it, OpenSSL I think is the easiest way already, so if you're going some other means, like, just go for it. And, the watch has its own OS too. Why? All right, so that's my last slide. I want to start talking about a reverse proxy. So let's clean up a little bit here. And for that, we're going to use nginx. So, and it's usually advertised as a load balancer. It's used for a lot of different things. Our specific application of nginx in this class is going to be as a reverse proxy. nginx, in general, I like to call it a web server, even though I don't think they call themselves that anymore. It's always like load balancer. I don't know why. Deliberate scale. Doesn't really say what it is, to be honest. Maybe Wikipedia will give us a better one-liner. Does it say web server on there? Okay. Oh, that was Wikipedia on the side. Okay. Yeah. Nginx is a web server that can also be used as a reverse proxy. We're going to use it as a reverse proxy. Load balancer, which is what it's, I don't know why, but it's like referred to as a load balancer. Like if you ask somebody about Nginx, they're like, oh yeah, the load balancer. It is, one of the best features of it, arguably, but as a HTTP cache, this is one of those things where we say, there's a few parts of the course where we say we do this to break caching. Nginx is one of the entities that's going to aggressively cache things, where we want to break that caching and make sure our server actually gets things. So the idea of a reverse proxy is that nginx is going to sit in between the internet and our app. So when somebody connects to our site, they're not connecting to our app directly. Our app is sitting somewhere nestled into our server, nice and cozy, and then nginx is going to communicate with the outside world with us, or for us. So somebody makes a request for our website, they're actually talking only to nginx. And then nginx is going to serve things. Nginx can do all those features we mentioned. It can host your static files, is one of the things nginx is really efficient at. So if you want to host your static files using nginx, it will just serve those static files, and your server never needs to know that somebody requested your HTTP, your CSS, your JavaScript, any of that stuff. As long as you're not templating your HTTP server side, then nginx is really efficient at that. Very aggressive caching, very efficient, very optimal for that. We won't use it for that. I suppose if you want to set that up, I'm not going to stop you for the homework. But that's one thing. And then when something needs to be sent to our server, the way we're going to use it is we're going to use nginx as a reverse proxy, meaning people connect to nginx, and nginx forwards that request to our app. Our app sends the response to nginx, and then nginx is going to respond to the end user. The advantage of this, one of the advantages of this, is that nginx can do all of the encryption. So nginx can have our self-signed certs installed, which is what you'll do for the homework, which that demo won't come until Wednesday. Nginx can do all the encryption stuff. So all of this communication with the client is going to be encrypted. Nginx is going to decrypt and then send HTTP requests to our server. So our server still only needs to speak HTTP and WebSockets, whereas Nginx can speak HTTPS and secure WebSockets, or WSS. So everything with Nginx encrypted, everything with our app unencrypted, and that unencrypted communication is internal to our server. So for somebody to eavesdrop on that, they have to have access to our server, which at that point we're already screwed. So what's the point? So the communication between Nginx and our app, unencrypted, but if somebody can see that communication, yeah, it's all over. It's game over already. So Nginx is going to handle that communication. Another good use for Nginx, one of the big reasons why I use it, why I like to use it, is I have multiple apps running on the same server. I actually have this open. I can pop it open. So I have got I got booted out. So on this server, I got, one of these should be the default. Oh, it isn't. I got 8 apps, 8 servers running on the same server. I'm wording that weird. 8 web servers running on the same DigitalOcean droplet. So DigitalOcean droplet is like a virtual machine that I have control over because I give them money. And I run 8 apps on the same server. That's the best way to say it. It's 8 apps on the same server. And then nginx communicates to the outside world, and nginx looks at the domain name. What domain name are you requesting? And then I have it forwarding to one of those 8 apps based on that domain name. I don't think all of these are running at the same time. I think some of these I have down right now. But if we do docker ps, we can see these things running. I'm running 312.442 Towers Revival, which is jessehartloff.com. 115, which just redirects to something, and they don't really use it in 115. I wish they would, to go to CSE115.com. I don't know why they're resisting that. And I forget what some of these other ones are. This one doesn't do anything right now, but 2 of these, not Spring Break and the best website ever. These were domain names chosen by the class. We'll do that later this week as well. So I don't think I have anything running on those. I think Course Pages is 116. So I don't have anything running on these right now, and this one's defunct. So I got 5 apps running on the same thing, and then nginx is routing for me. So it's acting as a reverse proxy for 5 different apps simultaneously. So this way I don't have to give DigitalOcean $5 more a year for each app that I want to run, which would be painful for my wallet, my bank account. I'm just paying for the minimal server. Bless you. These sites don't get nearly enough traffic to be able to utilize an entire machine, even running Towers Revival, which is the most expensive one in terms of CPU, processing power, and RAM. It doesn't come close to using up that half a gig of RAM. You really don't need much for these things. And I'm running all these Docker containers. Docker's nice and lightweight. My apps are nice and lightweight. Towers is a bit inefficient in the way I'm using WebSockets, but whatever. But anyway, we can run multiple sites on the same app that way with DigitalOcean. So that's the biggest feature that I like from DigitalOcean, from nginx, is that I can use the reverse proxy and then use that to host multiple apps on the same machine. The load balancer, you would have multiple instances of the same app, and then nginx would choose which one gets each request. So if you have 5 instances of the same app, the load balancer would say, okay, nginx gets a request from a client. Which one of those 5 is least busy, and then sends the request to that one. And that's how you can have your distributed systems. 5 apps on the same server doesn't make much sense. But if you have a distributed system and you have a server room filled with racks of servers, then you have nginx as your entry point in deciding which box to send that request to. So you can scale up to an entire server room full of servers for your app as you get more and more traffic, more and more simultaneous users. So nginx can be the load balancer to be able to really handle your distributed system stuff for you. We're not going to do any of that. We're just going to use a reverse proxy. So let's see how to set this up. I want to do at least the basic setup today in the next 5 minutes. And hopefully I can get this live demo to work. So what I want to do, I'm going to create a new directory. So I want a new Docker container for my nginx app. So what I'm going to do is create a separate directory. I like to keep things separated. So I'm going to create a new directory for nginx, which is going to have its own Docker file, which is going to be from nginx. That's going to give me nginx, and it's going to install nginx on my machine. And then I want to set up some configuration for nginx. I'm going to have to cheat a little bit here. I'll see how much I can do from memory. But we want to, apparently not even the first word. So we want to listen on port 80. We want our server name to be localhost. And we want to redirect anything that matches slash, so absolutely any request. We're going to match that and send proxy server and send those requests to wherever we're going. So since we're inside, let me make sure I got the syntax right on all this stuff first. Server listen 80, server name localhost. I got to name it server. Location goes here. Proxy pass. All right, let me cheat a little bit just so we can get this by the end. So I want to create a server. That was the word I was missing here. Listen on 80, server name localhost. Good. Location slash. This is saying anything that matches this path. So we can separate this into separate paths. You could do location slash image if you want to host your images through nginx, things like that. This we don't need, but proxy pass, not proxy server. So I get for trying to do this from memory. And then we're going to forward this request, any request, to our server. So we have to look at our Docker Compose setup. Remember what we named our app. This is the same thing as connecting to MongoDB or MySQL from inside our app. We have to use the host name that we gave it in Docker Compose because Docker Compose is creating a network for us. So we named this app. So in our configuration, the server name is app. It's whatever we named it in the Docker Compose file. So app, port 8080. Is that true? No, that's not true. Port 8000 inside that container. 8080 is the external, the localhost port. So port 80 inside that app container, that's the one we want to forward all of our communication to. I'm just going to copy this line. We're not going to get this by the end of the day, are we? Got 1 minute. I didn't even spell that right. Oh, I kind of want to know if I did this right, though. I'll have to explain this better, and I spelled default wrong. So I have to make sure I spell it wrong there. And then I should be able to do Docker Compose up. Let's just see. Okay, we'll do it next time. We'll do that next time. So hoping I could get it in at the end there, but so next time we'll do nginx. I'll probably start that over so I can explain everything in a bit more detail, a bit more slowly, and then install self-signed certificates to our nginx setup and have HTTPS on localhost with a self-signed cert. What is the CSE 312 course website URL? Oh, it's sad that the resign deadline's over because that's usually my answer to that question. You can just resign, you know. And yeah, once you submit, you can go. Have a great day, and I'll see you Wednesday.